Now, these next sections we're going to do are something that's going to kind of carry through with us because we're going to use and reuse some of these ideas. We're talking about the angles of polygons, and we're going to talk about the interior angles, and we're also going to talk about the exterior angles. Um, our vocabulary word for today is diagonal, which it hardly seems like something we ought to need to know about. But in a polygon, a diagonal is a segment that connects non-consecutive vertices of the polygon. I mean, if it's consecutive vertices, it's called the side. So it's non-consecutive, and it's called a diagonal. Think about with me, because I always want this stuff to make sense to you and not just be memorized stuff. Think about with me the idea of a triangle, rectangle, square, quadrilateral, and I'm just using those. Really, they're all quadrilaterals. Rectangles and squares are special types, and there are other quadrilaterals like rhombus and trapezoid and parallelogram and a kite, and we'll be talking about those. And then a five-sided figure is a pentagon. So just to sort of slow down and say that's got three sides, that's got four sides, that's got five sides. And I've got some pictures drawn here, and I want to talk about degrees of a triangle. I think we know because we've already dealt with it. There's 180 degrees in the three triangles inside a triangle. The three angles inside a triangle. For quadrilateral, one of the reasons I use rectangle and square to have this discussion is because you know that a rectangle and square has four angles each that are 90. So that's 360 degrees. And then a pentagon, I've drawn this pentagon over here. And I just want you to see how many triangles do you see? Three of them. If they're 180 each, then 3 times 180 is 540. 540 degrees. So ask this question, do you see a pattern? You may or may not see a pattern. I'm saying, when I say see a pattern, I mean it's these measures. And the pattern that I would like for you to see is that every time you add, every time you add 180, you add 180 to get to the next one. So in other words, every time we go up another side in our gon, we go up another 180 degrees in the interior measures. That's reflected by this formula right here, which says the number of sides subtract 2 times 180 is the sum of the interior angle measures. So for a triangle, right, a triangle, that's 3 minus 2 times 180, which is 1 times 180, which is 180. For quadrilateral, which we know, I mean, we already know these, I'm just saying this is how it would work. Its number of sides is 4 minus 2 times 180, which is 2 times 180, which is the 360 that we already knew the quadrilateral had. But that formula works, okay? That formula works. Now, I'm going to do some things with you besides the formula because I always like to make it make sense. But here it says, find the sum of the measures of the interior angles of a convex nonagon. That's 9 sides. If we use the formula, and you put 9 in the place of the n, number of sides, 9, then that's 7 times 180. 7 times 180 is 1,260. Real easy to do. Now here's some algebra in our geometry problem. And as we have seen many, many times before, you're either looking for two things that are equal, typically two things that are equal, or 2 or 3 things that add up to something. They first tell us that this is a parallelogram, and they want us to find the measure of each interior angle. Well, one thing I know for sure, they all have to add up to 360 degrees. They all have to add up to 360. So the 5x and the 5x and the 11x plus 4 and the other 11x plus 4 have to all add up to 360. Now, if I look at all those x's, I got 11x, and 11x is 22x, and 10x from the two fives, that's 32x. And then the 4 here and the 4 here is 8. So that's 32x equal 352. X is equal to 352 divided by 32 is 11. Once we know that, let me go back to the original question here. So they want us to find the measure of each interior angle. Once we know that x is 11, then we have to go back and plug the 11 in to everybody and see what the measures are. That'd be 55. That'd be 55. That'd be 125. And that would be 125. When you add all those blue numbers up, each of the angles, you should get 360. And that's what they said. Find the sum of the measures of the interior angles of a convex octagon. An octagon has 8 sides. So remember our formula was n minus 2 times 180. So that's 8 minus 2, which is 6 times 180, which is 1080. That's B. Find the value of x. Again, all 4, that is a quadrilateral, right? All 4 angles have to add up to 360. So if we take our 6x and our 6x, that's 12x. That's 22x. That's 25x. Then you take your number, which is just the minus 15. Those are supposed to add up to 360. So 25x is equal to 375 when you kick the 15 over. You add 15 to both sides. And x is equal to 15. Now, a regular polygon, I always think this is an interesting name because to me it's special if all sides are congruent and all angles are congruent. To me that's special. They call it regular, which regular seems like it should be just normal, but this is special. But the reason they call it regular is because it doesn't vary. And so that's the use of the word regular. So what is the measure of each interior angle of a regular triangle, quadrilateral, pentagon? Well, remember, triangle has to add up to 180 total, right? I'm just going to put that in parentheses, 180 total. So since there's 3 of them, they're 60 degrees each. We already knew that. We called it equal angular when we did it. We know the quadrilateral is 360 total. There are 4 of those equal angles. They're 90 each. We call that rectangle square. And the pentagon we said was 540 total because you keep adding 180. There's 5 of them, which means there's 108 each. So it's really easy to generate this. In fact, I like to draw this. If I was taking a test in geometry as a student, I would want to draw this or build this on my test when I'm doing this chapter and deal with this material, because I'd like to have a reference that I can look at really, really easy. Now, you got your sides 3, your sides 3, 4, 5, 6, 7, 8, 9, 10. We could go on to the 11, the 12, and so on. But those are the main ones we're going to deal with. I have named them. Hopefully you know the names already. Octagon, like an octopus with 8 legs. It's got 8 sides. A nonagon, 9. You kind of... The weird one I always think is the heptagon. It's like, what's that? It's 7. I don't know what that is. Heptagon. Okay, whatever. But as we've already noted, the triangle has 180 degrees. Quadrilateral has 360 degrees. Pentagon has 540 degrees. Because what are we doing every time? Adding 180. So we just keep going. We add 180. 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 and you just take a calculator or do it in your head, whatever, paper, pencil, keep adding 180. So then we have this column out here, which is degrees per angle. That's for a regular. So we divide the 180 divided by 3, 60. The 360 divided by 4, 90. The 540 divided by 5, 108. We saw that on the previous page, all three of those. So we continue, the 720 divided by 6, that is 120. So if there's 6 angles, they got to be 720 in all. You divide to find out the 120. The 900 divided by 7 is the only one that doesn't come out cute or even. It's 128 point blah, blah, blah. The 1080 divided by 8, 80 goes into, or 8 goes into 10 one time, goes into 28 3 times, and then it goes into 40 5 times. And the 1260 divided by 9 is 140, and the 1440 divided by 10, that's an easy one, is 144. So I don't have to memorize those because they're really easy to generate for myself. And then, like I said, if I had this table, I'd just be able to look at it. Now, the last thing I'll say is this comes from the formula, if you wanted to do it that way. And this one over here, we'll actually talk about later, but it's n minus 2 times 180 divided by n, right? Because that's what we did every time. We took that, divided by took the total, divided by the number of sides, because that's what you're doing here, is taking the total, that's the numerator, divided by the number of sides. Well, a mall is designed so that 5 walkways meet at the food court that is in the shape of a regular pentagon. I always like going to food courts. So many options, so many good things to eat. Find the measure of one of the interior angles. So they want to know the measure of an interior angle. Since there are 5 of them and there's 540 degrees total, we divide and we get 108. Or we could look back at our table and see that there's 108 just by doing that, not even doing anything else. 108, right? And next, a pottery mold makes bowls that are in the shape of a regular heptagon. Remember, a heptagon has 7 sides. Find the measure of one of the interior angles of the bowl. Well, the easiest thing to do is look back here and see that's 128 point blah, 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 because it's 900 divided by 7, which is 128.57. Answer was B. Here's a different one. This is almost like an IXL type question. The measure of the interior angle is 150. So in this case, still asked us to find the measure. They told us the measure. Okay, whatever. 150. 150. How many sides has a measure of 150? Well, I go back in my table, and I don't think I got to 150. Man, I got close, but I didn't get to 150. Like I'm going up, but I didn't get to 150. So I might go another 1 to 11 and 12 and see if it worked that way. Or I could, if I can find it, I could go back to the problem and I could remember. It says find the measure of an interior angle, or the measure of an interior angle of a regular polygon is 150. Find the number of sides. So what I could do is, remember a while ago I said this is the total of all the angles. This is the measure of 1. So that's 150. So I could fix this or solve this by multiplying both sides by n. I need to distribute the 180 n minus 360 equal 150 n. If I kick the 150 over there, 150 n, I get, it's a subtraction, so it'll be 30 n. And if I kick the 360 over that way, it'll be a plus. Divide both sides with 30. That's a 30. N is equal to, I can't do math. Let me clean it up. Divide by 30. N is equal to 12, which we kind of thought maybe 12 was the answer. They did something similar here. Remember that? We had that, and so N is 12. So, like I've said, you just need to see the big picture here and keep putting these pieces together and see how things fit. The more you can understand it, the better off you are. Interior angle 144, we actually had that on our chart. It was D. We could have done what we did in the previous problem and find it. How many degrees are in a circle? All right. So how many degrees does it take to go all the way around? If you make a 360 degree turnaround, you're right where you started. You need to make 180 if you want to go in the opposite direction. So how many degrees all the way around? 180. 180. 360. That's how many it is. 360 degrees all the way around. So we know that, now we've been talking about interior. Our discussion so far has been interior. This is exterior. We know that the exterior angles of any gon, period, is 360. I don't care if it's a triangle, rectangle, whatever. It's 360 degrees. I could prove it to you, but I'm not sure we want to take that kind of time. So here is a many-sided gon, okay? We could count them and see. But it's a many-sided gon. But we don't care about the interior angles and the interior angle measures. What we care about is the exterior angles, which they have to add up to 360. So when we add all of these up, we get 360. That's what we're going to get, 360. So I'm just going to start here. 5x, 7x, 13x, 17x, 22x, 26x, 31x, 31x. Then I'm going to do the numbers. 5, 8, 20, 23. Oh, I think I messed that up. Try it again. 5, 8, -4, -1, -6, -12. So 31x is equal to 372. X is equal to 12, I think. Yes. Now, what they asked me to find? The value of x. X is 12. What could I do? I could then plug those in, at 12 in. In fact, it says find the measure of each exterior angle of, that's a different problem. Sorry. So I could plug that 12 in and find out all of those, and then I could add them up and see if they really do add up to 360. If I wanted to check, I could do that. So this says find the measure of each exterior angle of a regular decagon. Now, let me just take and do this first. I'm not going to try the whole draw the whole decagon. I'm just saying somewhere there is an angle inside a decagon, a regular decagon, which means all of them are equal. There's an angle, and going way back to our chart, we could look and see that one interior angle is 144. If that's true, then what's the measure of the exterior angle? Well, I hope you see that these two have to be supplementary, have to add up to 180. So if this one's 144, then this one over here is 36. 36. Okay? Now, I want to come back to that and do it again. I want to do it a completely different way. Exterior angle. How much does all of them add up to? 360 degrees. In a regular decagon, we get 10 equal sides, 10 equal angles. So 360 divided by 10, 36. Yes, it is that easy. So this is just more of the same practice. And let me do this one. exterior angle of a regular pentagon. It's 360 in all. Pentagon, there's 5 congruent ones. You divide 360 divided by 5. Answer, 72.